You have already learned to think of mechanical drawing as a language used by draftsmen and engineers. And since you are going to use this language also, you want to know exactly what it means. Suppose you are a draftsman. You have a draftsman's tools to work with, and you want to tell someone how to chair. The chair is only in your imagination, but you know how it should look, and now you have to tell someone else how to make it. You might describe the chair this way, with your hands, but that would not be very accurate. You might write down your description, but that would be awkward and would not make your ideas very clear. You might draw a picture of the chair in perspective, but this would show only approximately how the chair looks. It would not give details the chair maker would have to know, like the exact shape of the curved slats, for example. But now try another method. Think of the chair as it looks from different points of view. Think of the way it looks from the front. Then think of how it would look from the top if you were looking down, and how it would look from the right side if you moved around there to look at it. Then think of how these views of the chair would look if you could see them all at once. Make a drawing of the chair this way, in 3 views. This method of describing an object is called orthographic projection. You will use it in drafting to tell someone else how to construct what you have in mind. To see further how this method of shape description works, take a look at this bracket. Like most other objects, it looks one way from the front. From the top, it looks different, not the same as from the front. And from the side, it looks still another way. In other words, the bracket looks different from different points of view. Now suppose that in front of this object you can put a transparent plane, and from every point on the object you can extend lines perpendicular to the plane. These lines will create a view of the object on the plane, called the front view. It will be exactly like the object as you would see it from the front if you were an infinite distance away, though here the view is not quite the same because the camera is close to the object and cannot see in true orthographic projection. This front view shows the height and the width of the object. So far, however, this view shows nothing about the hole, which is hidden if you look at the object from the front. Extend projection lines from the hole to the plane and use lines composed of short dashes called hidden lines on the view to indicate such a hidden feature. Now imagine a second plane above the object and perpendicular to the first. Extend projection lines to create the top view. This view is exactly like the object as you would see it from the top. It shows the width and the depth of the object. Here too the hidden lines represent the hole, which is invisible. Then imagine a third transparent plane perpendicular to the others at the side of the object. Extend projection lines to this plane to create the side view. This view represents the object as you would see it from the side. It shows the height and the depth of the object. Now think of these perpendicular planes with the views opening into one plane, like the plane of a piece of drawing paper. And you have orthographic views which describe the bracket exactly. To understand the meaning of these views still further, try an experiment. Imagine that this rectangular piece of metal represents a plane. Notice that as it turns around, a plane looks shorter and finally appears as a line. Imagine a line turning around. Eventually, it looks like a point. In the same way, if you look at lines and lines at an angle from another direction, they appear as straight lines. And if you turn a circle around, it will appear as a straight line and then again as a circle. Now think about the planes and lines on the surface of an object this way, and you will see the principal graphic given in your textbook. A surface parallel to a plane of projection is shown in its true size. A surface perpendicular to a plane of projection is projected as a line. A surface inclined to a plane of projection appears foreshortened. That is, it looks shorter on the view. A line parallel to a plane of projection will show in its true length. A line perpendicular to a plane of projection will be projected as a point. An inclined line will have a projection shorter than its true length. Though we have projected only 3 views of this object so far, 6 views could be made if they were needed, including the left side and rear views and the bottom view. But these views do not tell you anything more about the object. The bottom view is like the top view, but not as clear because it shows details by hidden lines. The rear view is similar to the front view, but it has more hidden lines than the front view. The left side view is like the right side view, but it too shows important details by hidden lines. It is better to use those views which have fewer hidden lines. In this case, the front, top, and right side views. How do you know that these 3 views describe the bracket completely? Well, the top view shows its width and depth and part of the shape. The front view shows its height and width and more of the shape. And the side view shows its height and depth and completes the description of the shape. But to make sure that these views describe the bracket completely, see if they give you enough information so that you could construct it. Imagine that you're going to cut the bracket out of a block of material. The front view tells you how high and how wide the object should be and shows part of its shape. The hidden lines indicate an invisible feature, and the perpendicular line shows that the front face is cut off somehow, but the meaning of these lines is not clear without the other views. The top view shows where the front corner is cut off and how deep the bracket is. By this time, the hidden lines indicate a hole, but you do not yet know its shape. The side view shows the shape of the curved surface and the size and location of the hole. When you think of all the views together, as you have just done, you discover that they tell you the exact shape of the object. The definition given in French and Svensson's mechanical drawing should now be clear. Orthographic projection is the method of representing the exact form of an object in 2 or more views on planes generally at right angles to each other by dropping perpendiculars from the object to the planes. When you, as a draftsman, describe an object this way, in the language of orthographic projection, you will give the workman the exact information he needs. The chair can be made because you have used an accurate method of shape description. This is the meaning and purpose of all mechanical drawing.